Hello students. This video will show us how to do a couple normal distribution type questions. So I'm going to use an example that's similar to the example that you can find in your course package. The example reads IQ, or intelligent quotient, is assumed to be normally distributed with a mean of 100 and a standard deviation of 15. What is the probability that a randomly selected individual would have an IQ greater than 122? For part A. So a few keywords that we need to recognize. Normally distributed. So the data has a normal distribution. It has a mean of 100 and a standard deviation of 15. These values here correspond to the x values that we're going to need later on in our formula. So those key values in the question tell us that we can apply or use the Z formula, help us understand and calculate the probabilities associated with each of those different x values. So let's go to a whiteboard application. What we know is that because it follows a normal distribution, we can draw this bell curve, which looks something like this. It has a mean of 100, has a standard deviation of 15. The question states in part A is what's the probability that it is greater than 122. So I'm going to choose a different color here. 122 is going to be somewhere there on that scale, and we're going to shade in this area here because that's the area that we're looking for. Area for normal distribution is similar to the probability. So when it's asking for area, it's asking for the probability. Let's change back to this color. We can calculate a Z value. We have the x, 122, minus the mean, 100, divided by the standard deviation of 15. So our Z value is going to be 1.47. Keep in mind that a positive Z value means it's above the average, which 122 is above the average of 100. That Z value is going to correspond to an area, or level of probability. So that area, we look in this chart, which is on page 131 of your course package, Appendix B. So the Z values are going across down the left column and across the top. The interior values always correspond to a section in the middle of the bell curve or the normal distribution curve. So to find that area, we find 1.4 down the left column, there's 1.4, and 0.07 across the top. And the intersection of that, this value right there, 0.4292, is the size of the area from the middle to the Z value of 1.47. So now we know that the area is 0.4292. This value here basically corresponds to this area right in this bell curve. However, we don't want that area. We want that area that is shaded in blue. So let's go back to blue. To get our final answer, we're going to subtract that first area from 0.5, and we get 0.0708. So the probability of randomly selecting an individual with an IQ greater than 122 is approximately 7.08%. Why do we subtract it from 0.5? We have to remember that the mean, this value here, is in a normal distribution with the distribution of the curve symmetrical. That mean also represents the median. So half of the area would be 0.5. So that's why we subtract the area we get in the second step from 0.5 to find the missing section of the bell curve. So let's take a look at question 2. Question 2 states, what is the area, or what's the probability that a randomly selected individual will have an IQ less than 82? So one question students always ask me is when do we subtract 0.5 and when do we add 0.5. And I always tell them, a whole lot easier to understand when you do that by first drawing out the normal distribution. So the average is 120, the average is 100, has a standard deviation of 15, and we want to calculate the probability that it is less than 82. So let's put 82 right there. 82 is less than the average, so it's on the left side of the distribution, and that's the area we want. So I'll go back to a different color. So the first step in this process is taking the x value, 82, minus 100, divided by 15, the standard deviation. So z will equal negative 1.2. The z value is negative because it's on the left side of the distribution. Step 2 tells us we need to find an area associated with that z value of negative 1.2. So go back to our chart. There is 1.2 right there, and there is 0. So the area is 0.3949. 0.3949. Oops, I'm sorry, 3849. So this area here, let's put it indicated in yellow, is this section. Remember that this part of the normal distribution is an area, total area 0.5. So we have just found that part of that half is 0.393849. So that area or a section of the part of the normal distribution that's less than 82 would be 0.1151 would be the difference. So once again, we are subtracting the area we get in step 2 from 0.5. So approximately 11.51% probability or chance of randomly finding an individual with an IQ less than 82. So let's work on third question. This one states, what's the probability that an individual will have, a randomly selected individual will have an IQ greater than 87? Yeah, let's go back to our, I'm not sure why we're having some technical difficulties, but we are working on part C, that it is greater than 87. So we're going to draw out the normal distribution. There is a value of 100. There's our standard deviation of 15. And we want to calculate the probability that it is greater than 87. So let's put 87 in blue here. There's 87. 87 is less than 100. So that's why we're on the left side of the distribution. But we want to calculate the probability that it is greater than this amount. So we want the probability of all of this section. Pretty big section, and that's something that will help us when we go into step 3, understanding what we should do to get that final adjusted answer. So let's work to calculate our z value. Z value, as you can see, is going to be negative because we are on the left side of the distribution. The z value here is going to equal negative 0.87. When we go to the normal distribution chart, we're going to have there's negative 0.8, and here's 0.07. So our z value is going to be, our area is going to be 0.3078. So the corresponding area, 0.3078. Once again, this area here corresponds to this section. The area always corresponds to the area from the median to the x, or to the z value. To get our final answer, step 3, would be 0.5 plus 0.3078, which would be 0.8078. Why are we adding 0.5? We're adding 0.5 because this part of the distribution, 0.5, it equals 0.5 because it is everything from the median outward. So that this area here, right there, is 0.5. This area right in here is 0.3078. So we're going to combine them. That's why we add. So the probability of randomly selecting an individual with an IQ greater than 87 is approximately 80.78%.